So this video will focus on organic synthesis. So we're looking at AQA, A-level chemistry, and organic synthesis. What I would say about organic synthesis is it's not a stand-alone topic. And it's not a topic that is taught on its own. It's 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 the last thing we mention towards the end of the syllabus. So on organic synthesis is about reactions. So I'm going to try to summarize in 5 minutes all the main reactions we've done for inorganic chemistry, and I'm going to try to do this in this little space here. With alkanes, the main reaction is the chlorine, and that's UV light, and you get free radical substitution. The other one is is combustion. Alkenes undergo electrophilic addition reaction either with bromine or chlorine, HBr, HCl, steam, and sulfuric acid to make ethanol or alcohols, halogenos, dibromo, and also polymerization. Halogenos can react with ammonia to form an amine. They can react with hydroxide to form an alcohol. I'm sorry, I am writing fast. They can react with potassium cyanide to form a nitrile. This reaction is one of the most fundamental reactions because it increases carbon chain length by 1. And the other reaction is in alcoholic conditions with hydroxide, it can form alkenes. And then with alcohols, and this is very important because if you can understand what I'm doing now, and with alcohols, you will understand synthesis very easily. Alcohols can be oxidized to aldehydes or carboxylic acids. They can be oxidized to ketones. And that would be a secondary alcohol. Primary alcohol is oxidized to aldehydes or carboxylic acids. Alcohols can also form esters if they react um, with a carboxylic acid. In all of these reactions I've mentioned, sulfuric acid, concentrated sulfuric acid um, is your catalyst. And alcohols can also undergo elimination to form alkenes. So that's all of year 12 chemistry, and that's a good summary of synthesis reactions. Then aldehydes and ketones, let's just write it like this. They can undergo 2 main reactions, either with KCN, HCl or HCN. They make a cyanonitrile, or with NaBH4 in aqueous conditions, they can form alcohols. So aldehyde ketones, 2 main reactions. Carboxylic acids, well, if you know acids, you know everything else. But one of the important reactions with carboxylic acids is where you have what I call triesters, fats, oils, which are esters of glycerol. But that in itself isn't, strictly speaking, organic synthesis. It's a different type of topic where you find biodiesel and soap and so on. Amines, benzene. You can get nitrobenzene. You can get uh, a phenylethanone or something like that, what we call acylation. You can get alkylation, methylbenzene, and you can have bromine, so bromobenzene. Benzene will require a catalyst, and you will need to know your catalyst. For the 3 reactions, apart from nitrobenzene, your catalyst is aluminium chloride or aluminium bromide here. With benzene for nitration, you need concentrated nitrate and concentrated sulfuric acid. Sulfuric acid is your catalyst. And the Last important reaction where you've got to know your um, synthesis is acyl chlorides, because an acyl chloride can react with water to form carboxylic acids. They can react with an amine to form an amide. They can react with ammonia to form an amide, and they can react with an alcohol to form esters. So those are the main reactions we can focus on. Now let's look at a few questions here which will focus on um, organic synthesis. And you will notice that there is a lot of repetition. Straight away, let's look at the first question. It's an alkene and it's had Br added. Electrophilic addition this is. How do I know? So now what I'm going to do, a very simple task of counting. There are 4 carbons here, 3, 4, 5, 6, 7, 8 hydrogens. On the right, 4 carbons, 3, 4, 5, 6, 7, 8, 9 hydrogen and a Br, which means I've gained HBr. So for step 1, I need HBr. Yeah. Now with step 2, because it's a ketone here, and I've got to know my reactions, J must be a secondary alcohol. The word 20 means secondary. Well, if you've got 2 bromo here, then that must be butan 2-ol. Yes. Step 3 must be acidified potassium dichromate as your reagents. And then look at step 4. You've gained a CN. Again, look at what you've gained. You've got CH3, CH2. You've got carbon, you got carbon. Oxygen, you've gained a hydrogen. And you've gained a CN. So that means in step 4 you used HCl. That's how easy it is to understand organic synthesis. My real tip here is when you are doing organic synthesis, look at the starting reactant or reactant, look at the product formed and count the atoms on both sides. It will tell you what you've gained or what you've lost. Then when you go through the question, then electrophilic addition and the reagent is HBr. Identify J, we've already done that, and it says state the reagent and conditions needed for step 2. Well, it's got to be sodium hydroxide aqueous heat under reflux. Okay, now with step C you can have HCN step 4, or you could have KCN and sulfuric acid or HCl. Marks schemes normally mention sulfuric acid, so let's stick to sulfuric acid. We've already done mechanism, so we can move on. Okay, let's go to the next question, question 2. Okay, it says an incomplete reaction in step 1. So again, what have we gained? We've got a CH3, CH2, Br, and on this side we've got a CH3, CH2. Yes, then in green you've got NH2 plus and a CH3. That means that's what you've gained, and that can come from CH3 NH2 because this is a nucleophilic substitution reaction. And how do we name the secondary amine formed? We will name this as on here. Now if we were to complete this mechanism, actually let me do this as a mechanism. Okay, so CBr, and then you got CH3 NH2, and that attacks the carbon there. That bond there is going to break, and you are going to form CH2 NH CH3. So we're going to call this N-methyl. N-methyl ethylamine. Ethylamine. Okay. Figure 1 shows two-step synthesis to make amine G. Okay. So to make amine G, show complete figure 1 by drawing the mechanism for step 1 and displayed formula of amine G. So let's look at step 1. You've gained a cyanide, haven't you? So that's what you've gained. So we got 1, 2, 2, 3, 4. That means we've got to start with the methyl. I'm going to draw this first because I need to draw this to understand what's happened. That means in step 1, I must have started with bromo, with something like this, 2-bromopropane, and that's got to react with potassium cyanide. So it says complete figure 1 by drawing the mechanism for step 1. So that means the mechanism is cyanide attacks the carbon and the CBr breaks there. Okay, so that's basically, and this is again a uh, organic synthesis question. Question goes on, complete figure 1 by drawing step 1, and yep, that's fine. Okay, these are other questions, but I'm only focusing on organic synthesis. Okay, if we look here, question 3, aromatic amine, that means gained NO2, which means for step 1 you need concentrated nitric acid and concentrated sulfuric acid. You've got to memorize these things, so I can't really emphasize on that. And then step 2, look at the change. You've gone from NO2 to NH2, so you have gained hydrogen and you have lost oxygen, so that's a reduction. Here it has to be tin and concentrated HCl. Okay, and the equation for nitration is, I always do it like this, NO2 plus H SO4 minus, and you can do this in 2 steps as well, and water. So I prefer to do this one. You can do this equation as HNO3 plus H2SO4 gives you H2NO3 plus and HSO4 minus, and then H2NO3 plus breaks down into water and NO2 plus. You can do it like that. Mechanism you know, but for the sake of it, I'll just do the mechanism. CH3, CH3, here's your circle. From here, it attacks the nitrogen because nitrogen's got a positive, and then your circle in the middle breaks. Nothing happens to the CH3s. Put a positive there, NO2 there, H there, and then the CH bond breaks. Okay, so that's basically for you to know how to tackle this question. Question 4, a beautiful question, a 6 marker, really good question to practice. Let's go through reactions at the time at each time. Number 1, electrophilic addition. 2, KCN, nucleophilic substitution. 3, reduction. Now how do I know? Well, you've gained a CN here, and if you look reaction 3, you've got 1, 2, 3, 4, you've got 4 carbons, you've got 1, 2, 3, 4 hydrogens, and you've got N2. What have you gained here? You've gained 4 carbons, you've got 8 hydrogens, 1, 2, 3, 4. You got 12 hydrogens, you got N2. So you've actually gained 1, 2, 3, 4. You've gained hydrogens. So you've gained 12 hydrogens. That means this is reduction, which needs hydrogen and nickel. So the reduction of cyanide or nitrile to amine needs hydrogen and nickel. And that's it, we've done the question. Um, the rest of it, it is a 6 marker. It does ask you for further things, but um, I just wanted to focus on those things there really. Uh, Identify the reagent that is warmed with isomer W in reaction 2. Well, that would be potassium cyanide. And here the condition is very important. It's ethanolic condition, ethanol. Okay, and the recommended reducing agent here is hydrogen and nickel. That's the recommended one. Okay, another really important organic synthesis question. Again, look, step 1, concentrated nitric acid and concentrated sulfuric acid. Again, reduction, tin and HCl, and this one's new, isn't it? So this is not an aromatic reaction, not an aromatic reaction, because an aromatic reaction is when something is directly added into the benzene ring. So electrophilic substitution is when something is added directly to the benzene ring. NO2 is added here. NO2 becoming NH2 is reduction. And then, so that means for step 3, you have gained COCH3, which must have come from ethanyl chloride. And if you look at step 4, that is also a free radical substitution reaction. CH3 has become H2Cl, so that's Cl2UV. Because a halogen can add across a double bond, which would be electrophilic addition, and the other time when halogen adds has to be free radical substitution. So what a wonderful question here. And then step 5 is nucleophilic substitution. So that's ammonia Cl replaced by NH2. That basically, to understand organic synthesis, you've got to know the whole of organic chemistry. But just look at the way I've done it. Okay, so that knowledge you've got to go back, and then the rest of this, it's all there now in terms of what's going on. Okay, question 6. An alcohol has become an alkene, so that's dehydration or elimination. What's the reagent? Concentrated sulfuric acid. This in step 2 has to be electrophilic addition, and because something's got to add across the double bond, so I would say you add bromine across the double bond. Compound G must be not HBr, bromine, because step 3 is nucleophilic substitution with sodium hydroxide in aqueous conditions. And step 4, I would say in the classroom, can you let me know what it is? Have a think, but that's actually esterification, because you've got an ester link. So what have you added here? Carboxylic acid. What's your catalyst? Sulfuric acid. Okay. Now you can slow the video down, and you can look at what I'm doing. That's why I'm just slowing this down to help you. What about this mechanism here? This mechanism is a classic mechanism where people get confused, but it's not a confusing mechanism. It's actually a nucleophilic addition elimination. Here's your nucleophile attacks the C and COCl. Okay, nucleophilic addition elimination. What happens next? OH, OH, put the positive on the oxygen, and then C, O minus, Cl, and CO, Cl. CCl breaks, lone pair goes back in, and the OH bond breaks. And that's it. Nice, easy question there. Okay. Um, what about uh, this one? Final question, question 7. Let's have a look at this again. Okay. So, can you see halogeno, alcohol? The only change is Br replaced by OH, so the reaction 1 must be nucleophilic substitution. Okay, give IUPAC name for this. Alcohols take priority, so 1, 2, 3. So how do we name this? We're going to call this 3-bromo. I'm going to call this 2-methyl propan 1-ol. Why are halogenos attacked by a nucleophile? Because Br, or the halogen, is more electronegative than carbon. So carbon becomes delta plus, bromine becomes delta minus. Bromine attracts a pair of electrons towards itself, showing it by an arrow, and therefore the nucleophile can attack the delta plus carbon by donating its lone pair of electrons. The infrared spectrum of Y shows significant absorption 1680 to 1750. That means Y must have a carbonyl group. So what is it? Well, let's do it here. Let's enlarge this, okay, and let's rub all of this out. Okay, let's draw out its CH2, OH, CH, CH3, CH2, OH. Both of these are primary alcohols, and because they are primary alcohols, that means they must both, for Y, must be like this, aldehyde. And because it's asking for displayed, I'm drawing it as displayed. Okay, so I drew out that, tells me it's a primary alcohol on both ends. And then what's Z? So the question says compound Z has an empirical formula C3H4NO. Give the structure of it. C3H4NO. So it's C3H4NO is the empirical formula. Change color. What must it be? Well, if it's got an N, it must have reacted with KCN. So what is the structure of it? Well, then the only thing I can think of is if I look at my Y, and that bit stays as it is, and then the aldehyde will become OH CNH, and the other end will become OH CNH. Let's do the molecular formula. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, 2 nitrogens, and I've run out of space, and 2 oxygens, which matches the empirical formula. So that's a very quick short video on organic synthesis. Some of the questions from the last 5 years of exam questions which I've just been through. So I hope you enjoyed that and found that useful. Thank you for watching.